This is the Day 1 mini lecture for Math 0530, Statistical Principles. You should have your handout for Day 1 ready to fill in as we go along. This is the Day 1 handout. Our objectives for Day 1 are to find place value of a digit in a whole number, round whole numbers to specified place value, solve problems by estimating, translate English phrases to algebraic expressions, and evaluate algebraic expressions, solve applications of whole numbers. Part A, identifying place value of digits in whole numbers. So we can use this place value chart to help us recall the places in large whole numbers. For the whole number 386,201,457, let me read that again. For the whole number 386,201,457, give the digit associated with each of the following place values. 10,000s. So in our place value chart, we see the 10,000s here in the 1, 2, 3, 4, 5th place from the right. So looking at our large number here, the 5th place from the right has what digit in it? It has a 0. In the hundreds place, the hundreds place is 3 places from the right. 3 places from the right we have a 4, because remember that was 457. 100 million. Where's the 100 million place? Well, that's all the way to the left, so it's the 9th digit from the right. Remember, it was 386 million, so in the 100 million is the digit 3. And in the tens place, 2 places. See, here's the tens place here. 2 places from the right is a 5. And finally, in the millions place, where's the millions place? It is 7 places from the right. So looking at our big number, 7 places from the right, we have a 6, because recall it was 386 million. Let's look at Part B, rounding whole numbers. In some situations, you don't need an exact answer. In these cases, rounding the number to a specific place value is possible using these steps. In step 1, we underline the digit with the place value to which you are rounding. Step 2, identify the digit to the right of the given place value. Step 3, if the digit to the right is 5 or greater, we'll add 1 to the underlined digit. This is called rounding up. If the digit to the right is 4 or less, the underlined digit stays the same. This is called rounding down. And all digits to the right of the rounded digit become 0. And note, any digit to the left of the rounded digit stays the same. Let's look at example 1. Round 5,673 to the nearest hundred. So step 1 says that we're going to underline the digit with the place value to which you are rounding. Well, we're rounding to hundreds, and recall that hundreds are in the 3rd place from the right. This is 5,673, so we would underline the 6. Step 2 says identify the digit to the right of the given place value. Well, the digit to the right is a 7. Step 3 says if the digit to the right is 5 or greater. It is. 7 is greater than 5. We will add 1 to the underlined digit. So the 6 will now become a 7. We'll be rounding up, so step 4 doesn't apply since step 3 did. All digits to the right become zeros. We had 2 digits to the right, the 7 and the 3, and we note that the digit previous to that, the 5, stays the same, so we have an answer of 5,700. Example 2. Round 2,675,782 to the nearest 10,000. Do you remember what place is the 10,000s place? That would be here, the 7 in the 10,000s place. So it's 5 digits from the right. Step 1, we've underlined that digit in the 10,000s place. Identify the digit to the right. It's a 5. Step 3 says if it's 5 or greater, well, it is 5. We'll add 1 to the underlined digit. So that 7 is now going to be an 8. And everything past that 8 will be zeros. And the digits previous will stay the same. So we have 2,680,000. Okay, that's rounding. Part C, solving problems by estimating. And this is where we can use that rounding to help us with estimating. Estimating allows you to check the reasonableness of your answer when you're using a calculator. You may not be able to add two large, precise numbers in your head, but you can add their rounded values and tell if the answer given by your calculator makes sense. This allows you to find your typos. It's easy to hit the wrong buttons on a calculator, and you want to know if the answer that your calculator gives you is reasonable. Example. Enrollment figures at a local community college showed an increase from 49,713 credit hours in 2013 to 51,746 credit hours in 2014. Round each number to the nearest thousand to estimate the increase. Nearest thousand, they're telling us. Okay, so our first number, 49,713, the nearest thousand, which digit is in the thousands place? Well, I hope you said the 9. So we're to look to the right of the 9, and if that digit is 5 or more, we round up. Well, it is 5 or more, so we'll round the 9 up. But what happens when you round a 9 up? That goes to 10, right? So we're actually going to have to change that whole 49 to a 50, and then everything below that, we put zeros. Let's look at the next number. To the nearest thousand, which digit is in the thousands place? Well, I hope you said the 1. So the digit to the right of the 1 is a 7. That means we're going to round up. We'll round the 1 to a 2, and everything else will be zeros. So what did they ask us to do? Estimate the increase. How much did it increase from 2013, which is our first estimate of 50,000, to 2014 of 52,000? Well, I hope you said 2,000 credit hours is our increase. So if we type this in the calculator, how would you do that? How would you figure out the increase using the precise numbers? Well, hopefully you're thinking, well, I would take the 51,746 and I would subtract the 49,713 to find out the increase. And if you do that, you would get 2,033. So based on our estimate of 2,000, our calculator result seems reasonable. Part D. Translate English phrases to algebraic expressions. A letter, which stands for an unknown number, is called a variable. Using numbers, variables, and mathematical symbols, such as plus, minus, multiply, divide, and equals, we can translate English phrases into algebraic expressions. Knowing these key words will make the translation easier. So I recommend that you refer to this table if some of these words are not as familiar to you. When you run across problems in your labs and when you're doing work in this course, you know where you have a table that can help you on this handout. Write each phrase as an algebraic expression. Use x to represent the unknown number. Number 1, the sum of 3 and a number. So there's that unknown number. This is what we're going to use for x. And it says we have a sum. Sum is under, of course we know this, it's under addition. So we know this is addition of 3 plus some unknown number. Now the interesting thing about addition is I could just as well have written x plus 3, couldn't I? Why can't I do that? Well, it's something called the commutative property. And that just means that the order in which we add two numbers doesn't matter. We'll get the same result either way. 5 decreased by a number is number 2. So a number, here's our x. 5 decreased by. What's decreased by? Well, notice we find that up here under subtraction. 5 decreased by a number. 5 minus x. Now, is subtraction that word commutative that I said before? Does the order matter for subtraction? Well, yes, it does, because we know that 5 minus 1 would not be the same if I wrote it as 1 minus 5. So it does matter about the order. So when I write a subtraction problem, I like to look back and be sure, is what I've written exactly what that says? Have I got the number 5 decreased by some number? And I believe I do. 5 minus x. 3 times a number. Here's our x. What is times? Of course, we all know that. That sounds familiar. Multiplication. So 3 times x, which of course another way to write that, we don't even have to put the dot. It's understood if we write it like that. I'll just put a little equals here, that they're the same thing. Let me go back up here and put an equals just to indicate those are the same thing. Number 4, a number subtracted from 83. A number subtracted from, well, there's subtracted from, we know that's subtraction, from 83. Now we have to be careful. Again, subtraction, the order matters. So it's either going to be x minus 83 or 83 minus x. So I'm going to write x minus 83 and go back and check, because that's what you do. You're careful on subtraction. A number subtracted from 83. Oh, does that look like I've subtracted a number from 83, or have I subtracted 83 from a number? It looks like I've done the wrong thing here. So I'm going to cross that out and rewrite this. Now I know that the 83 must come first. Now I have a number subtracted from 83. So it doesn't hurt to write the wrong thing as long as you check yourself. You'll catch the mistakes if you'll check yourself. The quotient of a number in 4. Quotient, which one is that? Well, here it is. It's the first one under division. So I know this is division. Quotient of a number, there's my x. So as it's read, we will write this one as it's read. The quotient of a number and 4. So I write the number first, the division for the operation, and 4. This one looks a little different. We have a comma in here. That means we think about the first part first before and pause and then finish it. So twice a number. There's our x. How do you have twice of something? Well, if you said you multiply by 2, you're right. Twice a number. 2 times something, right? Pause. Now what do we do next? Increased by 9. Increased. That implies, notice under the addition column, addition. Twice a number increased by 9. And number 7 also has a pause in it, a comma. The product of 5 and a number. Product. What does that tell us? Product. That's the first entry under multiplication. So this is going to be multiplication. 5 times x. There's our number. Pause. Decreased by 25. Well, decreased we saw before, that's subtraction. So minus 25. And we know we've got that in the right order because we're going to check. The first thing, the product of 5 and a number, and then we're going to decrease that result by 25. Okay. Part E, evaluate algebraic expressions. We want to evaluate x minus 2 if x is 7. That means we'll place a 7 in for x. So 7 minus 2, and of course we know that is 5. That's what we mean by evaluate the expression. We're given a particular value for x and we plug it in. Evaluate 7 plus 3x if x equals 2. So in other words, 7 plus 3 times 2. Now this has two operations in it, so we have to think which one comes first. Well, I hope you said multiplication. Multiplication before addition, unless parentheses tell us otherwise. And so we're to multiply the 3 times 2, which is what? 6. And we still have the 7 plus, so 7 plus 6, 13. Evaluate x minus y if x is 9 and y is 3. So I placed it 9 where the x is and 3 where the y is, and 9 minus 3, of course, is 6. Part F, solving applications of whole numbers. So applications, that's like real-world problems or word problems. So in word problems, we have to figure out all the parts and the operations. So it takes reading a couple of times to figure out what they want. Let's read it through once first. A golf pro orders shirts for the company sponsoring a local charity golfing event. Shirt size large costs $32, while shirts size extra large costs $38. If 15 large shirts and 11 extra large shirts are ordered, find the cost. So we've got $32 large shirts, and we know we bought 15 of those, and $38 extra large shirts, and 11 of those. So I'm seeing that I'm going to have 15 times 32 to get the cost of the large shirt. So that's multiplication. But then I've got another size, the extra large, which I'll do 11 times 38, multiplication. But then I've got to add all that together to get my final result. So multiplication and addition. So I've got 15 large shirts at the cost of $32 each. And then I'm going to add to that 11 extra large shirts at the cost of $38 each. And that should give me my result. This is going to be the total cost of the large shirts, total cost of the extra large shirts, and then I'll add those together to get the total cost of the order. So 15 times 32, and I get 480, plus 11 times 38, 418, and then the sum of those is 898. So I can answer my total cost is $898. Let's put this over here. $898. Okay, a box can hold 24 cans of corn. How many boxes can be filled with 648 cans of corn? So one box will hold 24, and I have 648 cans. The question is, if I distribute 648 cans into boxes, how many boxes will I fill? So I'm dividing 648 cans into these boxes. So it sounds like a division problem, right? So 648, and I'm going to divide those cans up by 24 per box to determine how many boxes I will fill. And the answer is 27, so we have 27 boxes will be filled. Find the average of the numbers 76, 49, 32, and 47. So how do we find the average of numbers? Well, we add them up and divide by the number of numbers we added together, right? So we'll add 76 plus 49 plus 32 plus 47. But we're going to add first, so I'm indicating, let's put that parentheses. All that happens first, and then we'll divide by how many numbers? 4. So we add all those up, 204 divided by 4, and our result is the average is 51. Now, why did I have to put parentheses? Because in the order of operations, division comes before addition, and I want the addition to come before division, so I indicate that by putting those in parentheses. So that's the end of the mini lecture. On your checklist here, you are to explore MyLabs Plus and the multimedia textbook, and then start on your lab. And if you finish that, you can work on your 1530 assignments. Let's look for that multimedia textbook to be sure you know where that is. In MyLabs Plus, when you log in, on the left you see the navigations, and you can find something called Multimedia Library. If you click on that, you'll see choices for all the chapters in your book and the sections, and you can choose what you'd like to see. So here's the multimedia textbook here, and perhaps we would select chapter 1 and section 1.2 and click on multimedia textbook, and then you say find now, and down here at the bottom will be the link to take you to the pages of the textbook.